Can you hear me?
Hocam, we can start with the first presenter, Dania Abdel-Aziz. I think she's here.
Beni duyabiliyor musunuz? Can you hear me?
Dania, I think you have a problem with your microphone. We cannot hear you.
Can you hear me now? Hello. Telefonda problem mi var? Siz beni duyabiliyor musunuz acaba? Bilgisayardan.
Hocam, ayağını kapalı.
Telefonu kapatıp bir hocam konuşayım, bir test edelim. Evet. Tamamdır hocam, sağ olun. Hocam, Daniye duymuyor hocam sanıyorum. Abdirahman, can you hear me?
Yes, of course I can hear you.
Okay, so we can start with Abdirahman.
Thank you.
Okay, hello everybody. This is session 21 of International Students Science Congress. I am Hüseyin Yeşilyurt. I am the section chair. In this session, we have 6 presentations. So Abdirahman will present the first presentation. So you have 15 minutes, Abdirahman. We can start if you want.
Thank you very much. I really appreciate for this great work, and I would like to start my work. But let me first share my slides with you, if you can hear me. So, and I will kindly request if there is any discontinuity of my voice or whatever, you can interrupt me. You can tell me like my voice is low or the quality is very poor, whatever. And now I am trying to share with my PowerPoint.
Okay.
Yeah. If you can see or not, I don't know.
You can see Abdirahman.
Oh, that's great. That's great. So let me take the laser. Okay, I'm not wasting too much time. My name is Abdirahman Ahmed from Somalia, PhD student in Izmir, actually with the Department of Urban Renewal or Urban Regeneration, whatever you call it. Today, I would like to discuss something related to surface water resource management. And this project I have been working for the last 2 years. I have been studying, investigating, and making some interviews related to how we can manage water resources. As you are aware, there is only one renewable water. The renewable water is only surface water, so we cannot renew the groundwater. My task was how I can get a suitable solution for this abundant water who is getting less and less year after year. So my case study is concerned about Somalia, the river of Somalia. And the topic is how we can get a solution on these rivers to understand or analyze the riverbed, the shape of river, and the stream flow. So I will use some, what I can say, geospatial technology, particularly remote sensing and GIS as a tool. And I will use some data from Landsat 8. I will use some data from DEM, digital elevation model. So let me discuss a little bit deeper. As you know, or some information about, Somalia is in Africa, particularly in East Africa. If you can see this red laser I'm using here. So we have a border with Ethiopia, Kenya. So our water, resource water coming from Ethiopia. So we call Ethiopia upstream. If you know, like a river, they have only two sides, upstream and lower stream. So the upstream, where the river comes from, we call it upstream. It's from Ethiopia. We have two rivers right here. We can see it. There's two rivers. One is here, this line, and the other one is here. So my study is concerned only about this river from the upper one. We call it Shabelle. So before it reaches to Somalia, it has two tributaries, two parties. One we call it Fafan, and other we call it Webi Shabelle. When just before they reach Somalia, they join and make a river. Someone is calling me, I don't know, Admit, I don't know, who is this? Can I do something? Admit or something. Okay, I don't get it, I'm sorry. So my study, the case of the study is the catchment area, the river where the water accumulates, we call it catchment area. So the catchment area is about 297,000 square kilometers. So the catchment area, don't confuse with other. Catchment area is whole area where the river gets from water, either comes from water or gives water. We call it catchment area. So in that particular time, I'm using about SRTM data or USGS data. USGS data is like a page we can get all the data related about topographies, how the land changes. And also, if we talk about the length of the river, so there are two different things. One is the catchment area, the whole area. You can see a yellowish. Other we call it about the length, the river bed, how it starts from this position until the end. It is around 2,526 kilometers. In this kilometer or this length, half of it is in Somalia. So, and also when the river comes to Somalia, the river water, it is 2.4 billion cubic meter a year. So, which means this amount of water is we are getting. But let us talk about a little bit about the plan of Ethiopia. The Ethiopia upstream, this data is not about the data from Somali country or Somali, what I can say, National Minister of Planning. It's about the data I get from Ethiopia, Minister of Water Resource Management. So they say in 2005, we call about baseline, the time I started, it is 3.9 billion cubic meter. They say this is the water. So if we plan well, Ethiopia suggested, if we plan well in upstream, it means if we make a dams, water catchment area, water regulation area, we can give Somalia in 2010, 2.6, which we have already experienced less than this. And 2020, we get about 2.4, 2.5. So there's one question is here. When we were in currently, we are getting, as I suggested in my previous slide, 2.4 meters. So this means we are getting currently less than what they were planning. So I mean, in 2020, we are losing, is the amount we are losing is like 34.4 of water is missing. My question is, if we are losing such kind of water, how we can get a solution? So my solution is suggested like this. I'm using a data we can call from a DEM, digital elevation model, is a data form we are getting from the satellite, how the satellite can take a picture image from the whole land. So that image, I have processed the riverbed. I analyzed the river, how the river is changing from year to year, how the water, stream flow means the water are getting less and less after year. So this is my schedule of working. The DEM data I've been using follow direction where the river are directing or where the water are going through, how is the data accumulating, and finally until I get the where highest water, or we can call drainage point. In this study, I have analyzed it, what we call about elevation model. Elevation is like how the land is topographically changing. Where is the high level, low level, how the land is shaped, changing from position to position. So in the elevation, we can see Somalia, the side of the river, the catchment area is in between. This is the catchment area. Only the catchment area I've taken, not whole country. the catchment area is in between -10 up to 748 meters above the sea level. So that's a good question. You can ask how we can get about minus. Minus means there is some area which is below this, the sea, which we can be a lowland, we can call about lowland, or caves, holes, whatever you can call it. So after this kind, I process it to get about the slope. Slope indicates how the land changes from position to position. It means the steepness of the land, the high level, low level, immediate level. So in that point, I was analyzing to know where we can see the highest level of water. We can see how the river changes from the position to another position. So we see that almost 88,000 kilometers, or in different way, we can change into hectare. So the river Shabelle allocated this land. And then this is the map of my country, and this is the study area. The study area I have taken in the corner of the slide, we can see the stream network. This we call a stream network, where we get, if you know about a river gets from water from two sides only. First, rainfall, second, lenses, natural lenses from the mountain, whatever. So, and those small lines are the lines where the water coming from in order to reach the river. So the green line is the main river. The small lines are the drainage, which gives or converts to the river. Then my question is, let me clear a little bit because I'm running out of time. My question or my point is how the riverbed is changing from position to position. So there's a good question. Why we're analyzing this image? Like, if I assume there's someone who has no experience about this kind of work, we see if we wanted to know the river shape, how river looks like, I have to consider all the dimensions which are affecting whether it's direct or indirect. So there is impacts or these parameters or factors. The first one is the stream lines. This line can change the shape of the river. If we assume if the rainfall, it is this side very high level, the river can change from this position, it comes to another way. So this only occurs for like every 8 years, it can happen once a time, every 8 years, if there is no human intervention. Let me come, this is the blue line. This is the river. This data I get from Landsat 8, and I process it using ERDAS image, and there's a software like GIS, assume like GIS, one software or one tool, is another one I have used it. I divided the catchment area into 21 catchments. 21 catchments, I mean like 21 areas where the water accumulates or comes together. This 21 area, I wanted to know which area has the highest level of water. So we can see a different color, blue, like light blue, dark blue, red, pink, whatever. So the reason I wanted, if you see, this is the river. It goes until down. When we reach this point, the blue line, it becomes like more. There's some very few questions you can ask. Why it's like here too much blue? Why is here less blue? Here is only the river, but when it reaches the river, this area, it also joins some other like river dams or whatever, where we can store water. So the satellite image just shoots all the water. After that, when I divided this 21 subcatchments, I want to select only few subcatchments, 1, 2, 3, to analyze it much deeper. Let me go this second slide. This you can see, this is the river. The red one is the river. This is the area we can practice agricultural area. This agricultural area, we accumulate much water. After that, in this 21 subcatchments, I have to get to know which has the highest one in terms of a regional area or settlements. Let me go a bit deeper in details. As I said before, there were 21. Only I selected 4, which are this pink one. We call it was number 4. If you can see it somewhere, this is number 5 or number 6. I have selected 4, 5, 6, and 8. You can see this is one area. We can understand or we can see how the riverbed changes from this position to another one. And this is also another place, and this is another place. So the best way for us, why we have selected these areas as our sample points, because this area has the experienced massive change from year to year, from position to position. Then I have used it to see the precipitation. As I said before, the rainfall is counted the highest factor which affects the riverbed. So I wanted to know the rainfall system. We can see the rainfall is getting, this point is less. Yearly, it rains in between 320, about 320, 330 millimeter, like per day. Is the measurement of the way we measure, and we wanted to know the rainfall intensity and the rainfall drops. When the rainfall drop hits the ground, we measure the length of that droplet and where it reaches. After that, I wanted to calculate about what we can call about normalized difference water index. Because when we wanted to analyze topographic, we analyzed 2 different things. We wanted to know where the people are located, where the settlement is, where the road is, where the manufacturers and whatever school is. That we could call about a natural classification. And other classification we call about indexed classification. Indexed classification is when satellite take a picture, it's divided to parts. We call this is vegetation area. This we call about water area, whatever it is. So this index is the index I wanted to know where water is. We can see here. It is like river from place to place. So it's very clear that the river is changing from point to point. It's getting direction to other direction. The question is why the riverbed was shaped this. Number 1 is about the elevation, as I said before, slope, the settlement is, or the human intervention. So I used this equation to analyze much deeper. I don't want to waste it if there is not interested someone.
Second, sorry, dear Abdirahman.
Yep.
You have 2 minutes more.
Yeah, I'm almost finishing. Okay. I'm almost finishing. So thank you.
Okay, thank you.
The second one is like NDVI. NDVI is like how we can classify the green area. This is the green area. So this is my study area. I take it from Landsat 8 in January 2017. And those are the places we can make some catchments, reservoirs, water river reservoirs, or water catchments. And last one, I will say thank you very much for this great work. I appreciate. If there is a question, welcome.
Okay, thank you very much for your good presentation, dear Abdirahman. Is there any questions? Okay, thank you very much again.
I want to thank you to Abdirahman for his presentation.
Thank you, thank you. If there is no any question, can I leave the group or am I supposed to stay? I don't know.
We will be pleased if you stay here, Abdirahman, because we listen to you.
Yeah, because I am in home, so my babies are disturbing me, but I'm ready. Okay.
Abdirahman, let me ask you, do you know Abdishakur Ismail Adam?
Abdishakur, the one I know, if he is Somali guy. I think he's in Somalia now. He's in Hargeisa or whatever, I don't know. He's not around.
Okay. Then let's continue with Dania.
Okay. The next one will be presented by Dania, re-examine conventional concepts in urban design. The conflict BTW urban space utilize the Elem.s power control case Amman Jordan. Okay, you have 15 minutes, Dania.
I will share. First of all, my name is Dania Abdel-Aziz. I finished studying Turkish language at İzmir Çorumluoğlu, and now I will start studying PhD in architecture at İzmir Yüksek Teknoloji Enstitüsü at Urla. Today I will speak about re-examine conventional concepts in urban design. I will study the conflict between urban space utilization and the elements of power and control. This study will shed point on Amman, the capital of Jordan, and will talk into depth about Amman downtown. Speaking about informal sector and these pictures
Dania, can you hear me?
Evet. Buradan ben sana mesaj gönderiyorum, sen dikkat etme.
Hocam, I think she has a problem with internet.
Tamam. Tamam, bakayım ben, belki yönden bir şey. Sen katılmıyorsun değil mi? Kongreye.
I think there is an internet connection problem with Dania.
Yes, I think so.
So let's wait for her
Tamam.
for 2 minutes.
Mustafa, sen bildiğin katılamayacağını ama Pelin Orhan'ın ilgisi var. O da mı katılacak? O ismini
I'm sorry for this.
Okay, Dania, welcome. You can continue.
Tamam. So the problem statement arises from the high unemployment rates in Jordan. We could see that the youth unemployment rate has been among the highest globally, and there is a high cost of living and increasing poverty. All these three factors affected of the flow of hawkers into urban centers here in Jordan, and especially in Amman. Hawkers are often regarded as an element out of space, like all the authorities wanted to remove them, and the absence of a reference for a working location for them in a city plan made many problems at a city level. The Greater Amman municipality always fight against these hawkers, but at the same time, they don't provide job opportunities for them, or they do not understand their needs. This study assumes that the population of the hawkers will continue to increase by time at Amman. So this research will suggest a solution by integrating hawkers into city plan, providing them with an ideal urban space. I will create more job opportunities. This will make the pressure less into the local authorities. This means a sustainable community. This means equity and comfort. I will go through the study methodology one by one. First of all, I collected literature review. Then I started with a field study. As I mentioned before, I took Amman as a case study, and especially Amman downtown, because it is the central commercial area here at Jordan. It has a high frequency of passing local people as well as tourists every day. This study covered 5 main streets King Faisal Street, Asada Street, Arida Street, King Talal Street, Shaban Street. The target population were for the hawkers, the pedestrian, the informal, the formal business, and the local authorities. How they have been integrated? The pedestrian, I published a questionnaire online and I got 170 respondents. And for the hawkers, I will explain after 2 minutes. And for the merchants, I made an interview with 12 business owners, and I made 2 interviews with the GAM staff. In order to assess the different needs for the wide variety of activities has been adopted by these hawkers, I classified them into 3 main categories: the food activities, the clothing activities, the entertainment activities. The study took time from May 2019 to June. It was for 2 months. The sample size was 152, and the floor space area was only 88 square meters. The questionnaire I talked about the hawkers, mainly I collected data from it about their activities, their location, their safety, comfort, uses, and others. But many of them, not many, like a few of them did not answer because they are due to fear. That's why I took observation to validate the results of my research. Now I will start with my analysis. The site potential that has been found from this study, hawkers likes to stay in a place that's located between various activities, which mean land use affects the location, high rate of visitors, and high frequency of mobility. Why this? Because they need to move from their homes to this place, and they want to attract more consumers. As seen in this table, you can see the percentage of hawkers at each street alone. The locations, as said by the hawkers, should be safe. How it should be safe? Should be easy to run away from to avoid arrest from the authorities. We should know that the hawkers, the informal sectors, has its own rules. How? Because every specific space has an owner, and this space going from generation to generation. We're now speaking about the same hawker unit and how it moved from one generation to another. This study through SPSS analyzed the data and came up with the most common unit size for each activity category was 1 square meter for food activities, 5 square meters for entertainment activities, and 4 square meters for clothing activities. The feed survey indicates that clothes and toys were among the most activities that hawkers tend to do, and it was mainly located at the King Faisal Square. These are now, I will speak about the conclusion and recommendations about this research. The desired unit size depends on the, as I mentioned before, about the category of the activity. So every category has a special needs. Every potential location should have a minimum and a maximum occupancy area. And we should also pay for the GAM for using this space. If we are speaking about the transport nodes and parking areas, we should relocate these hawkers at the entry and exit points. And these units should be static. We can't move them because we want to locate them at the pavement to allow bus and cars smooth movement. There was a successful case done by the GAM. They converted a parking that is not working at Friday days into a popular market as indicated here at Ras Al Ain. So we want to spread this successful case. To avoid the clashes between official owners and the hawkers, there should be a clear distance between them, and they should not apply the same service or sell the same category of goods. If we are talking about the minimum width for the pavement, it should be 4 meters to assure flow for pedestrian. We should now highlight that there should be a distance between each unit about 5 meters to assure free movement of pedestrians for hawkers to work sufficiently. So planners should first know the need of street hawkers. Take this conclusion into mind and assure to locate them into a place where accessibility is there, main activity is taken into consideration, the demand for this type of activity or this type of service of this type of good to take into consideration, and space comfort for all, pedestrian, shop owner, hawker, and the jam. So, in conclusion, we should say that hawkers should be involved in formulating and implementation the street roaming activity, because this will raise their awareness, they will feel more responsible to their community, they will be more committed to change. And this will help in finding a stable job for them and a better income for them. By this, hawkers will be a part of the city's social economic, not a problem with this fabric. Thank you.
Thank you for your presentation. Is there any questions?
I have a few words to say. First, I want to thank Dania. It's a very interesting presentation for me. It's a different topic for its architecture. And can you go to previous slide, Dania?
This one?
Yes. I think the most important conclusion is the last one. By this, hawkers will become part of the city socio-economic fabric, not a problem. This is a real problem. There are different problems like this. If we try to convert the problems into a part of the city, we can manage many problems. But if we still consider them as a problem and try to export them or get rid of them, they are getting bigger. So this is a real solution.
Thank you. I think they need just to, they want a convenient income. They want a static, like a stable job, so they will feel safe. And yes, you know that all tourists here come to Amman downtown just to see these hawkers and take photographs with them. So they also contribute not only for pedestrians, because many pedestrians used to buy from them, also for tourists. Like they go for touristic places here in Amman and they go just to take photographs with these hawkers. And I think these hawkers, when I spoke to them, they don't want to make troubles. They only need
earn money
to help their families. Yes. That's why if we located them into a correct place, this will benefit them. This will benefit the pedestrian, the tourists, the local authorities, by providing them with employment, with jobs, so the unemployment rate will decrease.
The same problem or a similar problem is valid for Turkey, for İzmir. So it's a general one, not a specific one. So I understand that we have to solve this problem by this type of solution. It's a good solution. My final question is, where are you at the moment?
Now?
Now, yes.
At a cafe.
Because I hear the voice of vehicles, buses.
Yes. I just wanted to be into the street. About people who are working at the street.
At the street, but behind you I see vegetations.
Yes, this is sustainability.
Are you in Urla? Are you in Urla?
What?
Urla'da mısın?
No, I'm at İzmir, at Buca.
Buca, okay, evet. Okay. Thank you very much again for your interesting presentation. Dania.
Thank you.
Professor Yeşilyurt, I think there is nobody else. Unfortunately, 4 of the presentations will not be presented, okay. I think. They are not here because we couldn't reach them.
Okay, so I think we may finish the session.
Yes.
Mr. Mehmet.
Okay,
thank you everyone for your good presentations.
And we also thank you, Professor Yeşilyurt, for your contributions to our Congress.
You are welcome.
This opportunity, thank you.
You are welcome. Thank you again.
Görüşmek üzere, teşekkür ederiz.
Bye.
Bye-bye.